This cloud security article is from the systemsarchitect.io blog. We're doing a deep dive into our checklist for least privilege enforcement. Least privilege means granting only the exact permissions a user, service, or process needs to do its job, and nothing more. In the cloud, one IAM misconfiguration can expose an entire account, so least privilege is one of the highest impact security practices you can adopt. This checklist covers 10 concrete steps across AWS, Azure, and GCP, from zero privilege defaults and resource scoped roles to just in time elevation, break glass controls, and automated revocation. Least privilege is the practice of giving identities only what they need to work, never a standing surplus of power. That applies to human users, service accounts, and applications alike. When permissions are too wide, a single compromised credential becomes a blast radius problem for the whole account. By the way, this article is a condensed version of the complete article on blog.systemsarchitect.io. See the full blog article and solutions on systemsarchitect.io. Like the video, subscribe to the channel, check the video notes for links. These 10 practices turn least privilege from a slogan into an operating system for cloud access. First, start every identity with zero privileges. Add permissions explicitly as needed rather than starting broad and promising to tighten later. That later almost never arrives. Temporary admin sticks. In 6 months on, you have dozens of service accounts with full administrator rights. Why deny by default? Deny by default forces a justified request and an audit trail for every grant. Keep IAM policy as code in version control. Require a pull request for any new permission and name policies with a clear pattern like team, service, and environment. On AWS, new users and roles start empty. Do not attach administrator access or power user access, and use IAM Access Analyzer to draft policies from 90 days of CloudTrail usage. On Azure, new users inherit nothing unless a management group grants it. Start with reader only when visibility is needed. Prefer custom roles and use deny assignments for hard boundaries. On GCP, new service accounts start with no roles. Skip primitive owner, editor, and viewer in favor of tight predefined roles, and use IAM recommender to strip excess based on usage. Second, grant only required permissions. Map every permission to a real job or automated task. If a developer needs log lines, grant something like logs get log events, not log star. If a Lambda function writes one DynamoDB table, grant put item on that table ARN, not on every table. Over-permissioned identities dominate cloud audits. Studies have found most identities use only a tiny fraction of what they hold, and each unused permission is a attack surface. Cloud-native analyzers over a 90-day window catch infrequent but real use. Remove what was never used and accept that re-adding a rare permission later is safer than leaving the barn open forever. AWS Access Analyzer can generate a policy from CloudTrail that lists only used actions, resources, and conditions. Azure AD Access Reviews push managers to confirm or drop access, with auto remove if nobody confirms within 14 days, and workload identity reviews for service principals. GCP IAM Recommender suggests replacing editor with narrow roles like Cloud SQL Client and Logging Viewer, applied through policy intelligence tools. Third, use roles instead of attaching policies to individual users. Assign permissions to roles or groups, then place people and machines into those roles. What does role-based access buy you? Role-based access keeps sets consistent, audits simpler, and onboarding and offboarding faster. Direct user policies create snowflakes you cannot review at scale. Role moves flip permissions instantly when someone changes teams. Define roles by job function, not by person. Developer read only, developer deploy, SRE on call with time limits, security auditor across accounts, and keep total roles under about 20 to avoid explosion. On AWS, use instance profiles, Lambda execution roles, and ECS task roles for machines, and IAM identity center permission sets mapped to groups for humans, avoiding long-term IAM user keys. On Azure, map intra-security groups to RBAC roles at management group or subscription scope, and use privileged identity management to make elevation time limited with justification. On GCP, bind roles to Google Groups and use workload identity federation so external systems assume roles without service account keys. Fourth, scope permissions to the exact resource. Prefer a specific ARN or resource path over wildcards. S3 get object on one bucket path is far safer than get object on star. Why scope to the exact resource? Resource scope is where least privilege becomes concrete. A compromised function that can write one orders table cannot corrupt every DynamoDB table in the account. Drive policies from infrastructure as code so Terraform references like the table ARN stay correct when resources are recreated, instead of hard-coding brittle strings. On AWS, always name resource ARNs, add conditions such as requested region, and for S3, separate bucket level and object level ARNs. On Azure, assign RBAC at resource group or single resource scope, not the whole subscription by default, and use policy to gate broad subscription assignments. On GCP, use IAM conditions on resource name prefixes and bind at bucket, dataset, or instance level. For example, BigQuery data viewer on one dataset, not the whole project. Fifth, review privileges quarterly. Fifth, permissions drift when people change teams, projects die, and temporary access never expires. Without reviews, accumulation is inevitable. Cloud service accounts often gain features for years without ever losing rights. Automate a report of granted versus used permissions over 90 days, send the delta to the service owner, force mandatory review of admin level access, and revoke unreviewed access after a grace period if the review is overdue. On AWS, Access Analyzer and Service Last Access Details show stale roles, and config can flag full access statements. On Azure, quarterly intra-access reviews with auto-apply removal cover users and apps, and credential lists surface keys that should have rotated. On GCP, Policy Analyzer answers who can access what. IAM Recommender suggests cuts, and Asset Search into BigQuery powers dashboards of permission count over time. Sixth, implement just-in-time elevation. Can you explain what is just-in-time access? Just-in-time access grants elevated rights only when needed for a limited window with approval, then revokes automatically. An SRE investigating production should not hold permanent database admin. They get 2 hours of access that expires. Standing privilege is always on for attackers and insiders. Elevation with approval shrinks that window and leaves a trail of justification and approver. Cap duration by risk, for example, 1 hour for production databases, 4 hours for production infra changes, 8 hours for dev admin, and require a second approver for long elevations. On AWS, use Identity Center permission sets with short sessions or assume role with duration seconds for programmatic limits. On Azure, privileged identity management makes roles eligible rather than always active, with portal activation, optional approval, and 1 to 24-hour caps. On GCP, Privileged Access Manager defines entitlements, who may request, duration, and workflow, with grants that expire without manual cleanup. Seventh, audit all privileged actions. Log, retain, and review every elevated or administrative action for accountability, forensics, and deterrence. Without logs, you cannot reconstruct what a compromised admin did. With them, you scope damage in days, not months, and frameworks like SOC 2, PCI DSS, and HIPAA expect tamper resistant admin audit trails. Ship logs to a separate account or project admins of the source cannot delete. Use write once storage, such as S3 object lock, Azure immutable blobs, or GCS retention policies. Keep at least 12 months hot and multi-year cold for compliance. On AWS, multi-region cloud trail with management and key data events, object lock in a security account, and CloudTrail Lake for SQL-style analysis. On Azure, activity log for control plane plus diagnostic export for longer retention, and intra-audit logs for identity events like role assignment and multi-factor authentication changes. On GCP, admin activity logs are always on. Enable data access logs where needed, aggregate syncs to a central project, and lock log buckets for tamper protection. 8. Break glass only with approval. Break glass is emergency access when normal paths fail, such as single sign-on outages, and it must be approved, heavily logged, and reviewed within 24 hours as an incident. Without guardrails, it becomes a daily backdoor to skip change management. Store credentials offline or outside the primary identity provider. Require 2 people for retrieval and page security. The CISO and SRE leadership on any use. On AWS, a dedicated break glass IAM user with hardware multi-factor authentication, CloudTrail Event Bridge alerts on that username, and credential rotation after every use. On Azure, at least 2 break glass accounts excluded from conditional access, complex offline passwords, and sign-in monitoring per Microsoft guidance. On GCP, a cloud identity break glass user with organization admin, offline storage, and cloud monitoring alerts on that principal email. 9th, remove defaults immediately. Platforms ship defaults that favor ease over security. Default VPCs, default service accounts, default admin ports, and open-ish access policies that attackers already know. Default AWS VPCs can place instances on public subnets with public IPs. Default GCP compute service accounts often hold Project Editor. Ports 22 and 3389 are scanned first. Bake day zero automation into account vending. Delete or lock defaults, strip default security group rules, enable audit logging before any team deploys workloads. On AWS, delete default VPCs in every region, empty the undeletable default security group, and use service control policies to block recreating default VPCs. On Azure, harden tenant defaults, disable legacy auth, enable security defaults or conditional access, restrict app registration, and clean default contributor sprawl from setup. On GCP, disable the default compute engine service account, delete the default network, and use organization policy to stop automatic IAM grants to default service accounts. 10th, automate privilege revocation. Manual offboarding is slow. Lingering access weeks after someone leaves is still common and is pure entry surface. Tie revocation to HR and identity provider events so employment status change removes cloud access in minutes. Use SCIM provisioning from Okta, Entra, or Google Workspace into cloud accounts. Set service account expirations at creation. Alert on keys older than 90 days. On AWS, IAM Identity Center with SCIM deprovisions fast, and config plus Lambda can disable unused long-term credentials. On Azure, Lifecycle workflows and user provisioning disable accounts when status changes, while conditional access on compliant devices reduces risk if deactivation lags. On GCP, Cloud Identity SCIM for users, scheduled cloud functions to disable old keys, and IAM conditions with request time for self expiring bindings. To close, start every identity at 0 and grant only permissions that match real usage so a stolen credential cannot roam the whole estate. Prefer roles over personal policies and scope those roles to exact resources so access stays auditable as you scale. Use just in time elevation and approved break glass so standing privilege is rare, short, and noisy when used. Automate revocation from your identity provider and run quarterly reviews so access cannot outlive its reason. Those 10 steps make least privilege a living control system across AWS, Azure, and GCP, not a one time policy document. Well, that does it for now. Hope you got something out of this video. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io. That's systemsarchitect.io and codeguides.io.